The friction coefficient between a road and the tire of a vehicle is 4 by 3. It means mu equal to 4 by. So find the maximum incline the road may have so that once hard brakes are applied and the wheel starts skidding, the vehicle going down at a speed of 36 kilometers per hour is stopped within 5 meters. U equal to 36 into 5 by 15, that will be equal to 10 meters per second, and the distance S equal to 5 meter, and the V equal to 0. So let's evaluate it. Equation is like this. This is incline, angle is theta, and vehicle is here, it's going down. Now we can apply the formula to get acceleration first. So A equal to V square minus U square divided by 2S. So this would be equal to A, final velocity 0, initial velocity is 10 square divided by twice of 5. This would be minus 10 meter per second square. Now, we can consider the motion of the vehicle in this direction. So A we have got as minus 10 meter per second square, and all other forces. So in this direction there will be mg sine theta, and the normal will be in this direction, and its weight will be in this direction mg. Here this will be mg cos theta. So mg sine theta will act in this direction, friction will oppose it, and despite that, object will move with acceleration a. So let's apply Newton's law. So net force in downward direction would be mg sine theta minus friction, and due to this vehicle is in motion, so we can say ma. So we can put the value of friction. Friction is given by mu mg cos theta. So mg sine theta minus mu mg cos theta equal to ma. We can divide each term by m. Now, 10 sine theta minus mu is given as 4 by 3 into 10 cos theta equal to acceleration is minus 10. Now we divide each term by 10. So this will become sine theta minus 4 by 3 cos theta equal to minus 1. We multiply each term by 3, and then we take minus 3 to LHS. So we will get the equation 3 sine theta minus 4 cos theta plus 3 equal to 0. Now we have to solve this equation, and then we will get the value of theta. So let's write it as minus 4 cos theta equal to minus 3 common, then it will be 1 plus sine theta. We can square it, 16 cos square theta equal to 9, and this will become 1 plus sine square theta plus 2 sine theta. We open the bracket, 16 cos square theta equal to 9 plus 9 sine square theta plus 18 sine theta. Further, we convert it in terms of sine theta. 1 minus sine square theta equal to 9 plus 9 sine square theta plus 18 sine theta. So on simplification, because this is simple thing, on simplification, we will get 25 sine square theta plus 18 sine theta minus 7 equal to 0. Now we apply quadratic formula. So our equation is 25 sine square theta plus 18 sine theta minus 7 equal to 0. So sine theta equal to minus b, means minus 18 plus minus root of b square, 18 square, that's 324, minus 4 AC, 4 into 25 into minus 7. So this will become plus 7. Divided by 2a, 2 into 25. So minus 18 plus minus root of 1024 divided by 50. And this is equal to 30. Sorry, 32. Because square root of 1024 is 42. So we have got sine theta equals minus 18 plus minus 32 divided by 50, taking positive value. So it will become sine theta equal to 14 by 50 or 7 by 25, which is equal to 0.28. Now, theta will be sine inverse 0.28. Now, if we use calculator, we can get this in terms of degree, and that will be 16 degree. Now, let's go to the next question. Question number 15. It says the friction coefficient between an athlete's shoes and the ground is 0.9. Suppose a Superman wears these shoes and races for 50 meters. There is no upper limit on his capacity of running at high speed. Suppose he takes exactly this minimum time to complete the 50 meter. What minimum time will he take to stop? So here, acceleration A equal to mu g, mu is 0.9 and g is 10. So it is 9 meter per second square. So applying formula S equal to ut plus half at square, u equal to 0. So S is 50 meter. So 50 equal to 1 by 2, A is 9 into t square. So this will give t equal to square root 100 divided by 9, which is 10 by 3 second. Now we have to find out what is minimum time to stop. So let's find out the speed of athlete when time is this. So we apply formula v square equal to u square plus 2as. So v square equal to, starting from rest, 0 plus 2 into a is 9 into s is 50. So this is 900. So we will get v equal to 30 meter per second. Now, the time to stop, we can apply formula v equal to u plus 8. So here, v is 30, u is 0, and the time, or we can say starting velocity, this velocity here, the athlete velocity is 30 meters. He has covered the distance. Now either we take backward or we can take same distance in this direction, 50 meter. At this position, this is velocity. So take it as 30 meter per second. Here, athlete stops. It means v becomes 0. And a we have to take negative. So this will become 0 equal to 30 minus 10 by, sorry, A is 9, not 10 by 3. It is 9 times T. Our concern is to get T. So T will be 30 by 9, which is 10 by 3 second. Now, let's go to next question. Question is, a car is going at a speed of 21.6 kilometers per hour. It means U equal to 21.6 into 5 by 18. That is 6 meter per second. When it encounters a 12.8 meter long swift, here AB is 12.8 meter. 12.8 meter, and theta is given as 30 degree, and slope here. The friction coefficient between the road and the tire is 1 by 2 root 3. Value of mu is given 1 upon 2 root 3. So that no matter how hard the driver applies the brakes, the car will reach the bottom with a speed greater than 36 kilometers per hour. You have to take G equal to 10 meters per second square. Now, suppose car is here. In that case, normal reaction will be in this direction, and its a component of it will be mg cos theta. And in that case, friction will be given by mu mg cos theta. We can put the values 1 upon 2 root 3 into m into g is 10 into cos 30. Root 3 by 2. So here, let's cancel it 5 times. Root 3 will also get cancelled. 5 by 2m. So 2.5 m is the friction. Now, downward force, let's find out. So in this direction, force will be mg sine theta. So let's find out its value. Downward force, suppose we write it as F. So mg sine theta. So m into 10 into sine 30 degree is 1 by 2. So this is 5m. So friction is 2.5 m, which is opposing the motion. So net force in downward direction will be this minus this. So 5m, this is not 5 meter, this is 5m. 5m minus 2.5 m. That is 2.5 m, where m is mass of the car, and that will get cancelled. We use F equal to ma. But here, since F we have written as mg sine theta, net force we are writing as F1. So F1 equal to ma. So we can equate this. So 2.5 m is equal to ma, from where we get a equal to 2.5 meter per second square. So we have got acceleration in downward direction. Now we have to find out what is speed of the car when it reaches here. At this point, speed is given as 6 meters per second. So let's apply the formula. Formula is v square equal to u square plus 2as. We have to find out v square equal to u square, 6 square plus 2 into a. Acceleration we have found as 2.5, and this distance is given as 12.8 meters. So we simplify it. The product of these three terms will become 64, because these two terms will give 5, 5 into 12.8. So we have got V equal to square root of 36 plus 64. So V equal to root 100, which is 10 meter per second. Now, let's convert it into kilometer per hour. So V equal to 10 meter per second, which is equal to 10 into 18 upon 5. That is 36 kilometer per hour. So this is our answer. Thank you for watching.